The X13 motor is similar in design to an ECM motor. Both are classified as BPM, brushless permanent magnet. Both have a significant increase in efficiency over PSC motors. They use ball bearings instead of sleeve bearings. They have a three-phase motor. The module converts single-phase to three-phase for use by the motor. The increases in efficiency helped manufacturers achieve 13 SEER with many 12 SEER products, hence the name X13. Before diagnosing a motor, you want to make sure you've got proper power applied to the motor. 2 rows of connectors, high voltage on the back row to L, G, and N. L and N are high voltage, G is ground. Low voltage 24 volt common goes on the back row, but the connector is a different size. It's larger to avoid confusion. 1, 2, 3, 4, and 5 are the speeds. Unlike a PSC motor where high voltage is switched to the motor, the X13 motor has high voltage all the time at L and N. Check that, and then check for the low voltage triggers that turn the motor on and off. So on a package unit, the same voltage that pulls in the contactor is applied to the cooling speed, typically a higher number, and the constant fan or heat speed is applied to a lower number. On the package unit, there's a relay with a 240 volt coil that takes the motor voltage that would power a conventional motor and instead triggers a 24 volt relay that sends 24 volts to the heating speed. So again, first step is always confirm proper high voltage and low voltage to the motor. Checking the motor is 2 steps, electrical and mechanical. Mechanical failures are rare, but they do occur. The motor should spin freely. There are magnets attached to the rotor that should be firmly attached to the center rotor. If there's any mechanical failure, the entire motor needs to be replaced. If it's just a module failure, the module can be replaced, as you can see here, without even taking the blower assembly out of the unit. Unlike a ECM motor, the X13 motor does not require a special tester, it just requires a VOM. Because the motor is wired like a 3-phase motor, you would test it just like a compressor. With the connector removed, your ohmmeter set for continuity, you'll check continuity at each set of windings. Then also check continuity to ground. Resistance should be infinite to ground on all 3 legs. If the motor windings are intact, all that needs to be replaced is the module. It's a very quick operation. The modules can be reprogrammed at our branches. In other words, if you have a motor that ends in a -3 and you need a motor out of a -5, the motor head can be reprogrammed because the motor head determines what the horsepower and rating speeds are on the motor.